Project 2.1, Digital to Analog Conversion. This circuit I have here is a form of a DAC. It's called an R2R ladder. The purpose of this circuit is to take the digital input voltage of 9 volts and convert it to an analog voltage. It splits the voltage into 8 binary bits. As you move from left to right, each bit in the circuit halves the voltage. This can be explained using Thevenin equivalent circuits and superposition theorem. Thevenin's theorem states that any linear circuit with multiple voltage sources and resistors can be simplified into a single equivalent voltage source in series with one resistor. This helps us analyze each part of the ladder more easily. The superposition theorem states that in a linear circuit with 2 or more voltage sources, the total voltage in any part of the circuit is the sum of the voltages produced by each source acting alone, while all the other sources are turned off. By applying these theorems, we can break the R2R ladder into simpler sections and see how each bit affects the output voltage. With this in mind, we know that the voltage at this point is equal to the voltage at this point, just divided by 2. This is due to 2R cutting the voltage in half. As you move down the line of the resistors, the same goes. When you have this part of the circuit, the voltage to the left of R is the voltage at bit 0 divided by 2, because a 2R divides it by 2. Here near bit 1, it's similar, but when you have 2R in parallel, it's equal to R, except when you move across here, there's R. R plus R is equal to 2R. So again, with another 2R, the voltage is divided by 2. So when the voltage comes in from bit 0, it's divided by 2, and then divided by 2 a second time. This process continues down the line until the last bit. So first it'll be divided by a half, then a quarter, then an eighth, then a 16th, 32nd, 64th, 128th, and finally a 256th. Now let's see the voltage division in action. Here's my working finished prototype to demonstrate this. So we have a supply voltage of approximately 9 volts. So now we can see, as previously stated, the first bit divides it by half, and then the second bit divides it by a quarter, the third bit an eighth, and so on. When you add them all together, it gives you approximately the supply voltage.